Hello there, and Happy New Year to you all. Welcome to Slooh, Space for Everyone. I'm Jerry Montour, your host and expedition leader here, and absolutely thrilled to have you along for today's 2017 Quadrantid meteor shower. We are here to watch shooting stars as they race across the sky while planet Earth passes through the debris trail of a very interesting object called 2003 EH1. We'll tell you a lot more about that later on in our show. We'll actually be telling you a great deal today as we bring you live meteors from a couple locations around the world over the course of our 3-hour broadcast. And of course, we'll be joined by all of your favorite Slooh regulars. Journalist, author, and radio show host Bob Berman will be here to help us get to know today's meteor shower and what makes it so different from the others throughout the year. He'll also tell us about that thing that causes the shower in the first place. Slooh's human spirit correspondent, Helen Avery, will come aboard to regale us with mythological stories and a look at the way and why so many humans have feared comets and meteor showers throughout history. I'll also be joined by Slooh astronomer Eric Edelman of the Morrison Planetarium, who will give us a crash course in meteor shower basics, as well as Slooh astronomer Paul Cox, who will be popping in now and again to take us on a tour of our live feeds and offer some tips and tricks for your own meteor watching adventure. As a matter of fact, let's bring Paul on right now. Happy New Year, my friend. How are you?
And to you, Jerry. Yeah, very well, thank you.
Well, this was a big week for Slooh members, and we're going to talk about that in just a second. But as far as this meteor shower is concerned, it really is different for a couple of reasons. Number one, it peaks, doesn't it?
Well, all meteor showers peak, but the difference with the quadrantids is that the peak is very, very narrow. It occurs only over about a 3-hour period. And really outside of that, the number of meteors that you see are kind of almost not worth watching. I've actually never seen the quadrantids. I mean, it's an elusive shower. You have to be in exactly the right place at exactly the right time.
Well, I mentioned the feeds that we'll be watching over the next 3 hours. Take us through that, would you please?
Well, we've got two different types of feed tonight, Jerry. We've got Mauna Kea here, you can see, in Hawaii. They're still in the last few hours before dawn. And the peak of this shower is kind of happening around now. Now, these are long exposure images of a special type of camera. It's a low light camera. It gives us this 180-degree field of view. That's why it's looking round. So you can see there some of the mighty telescopes at Mauna Kea. You can see just to the left of you, actually, the constellation of Orion. Now, in this view, we're going to be seeing meteors that appear as a streak of light, and they'll stay in the view because they're captured in that static image. We can tell whether or not it's a quadrantid meteor if it's looking as if it emanated from the top left of this particular image. So it's the northeast. This kind of flipped around because we're looking upside down. But we also have another type of feed tonight, and that's going to be coming from our partner Weather News in Japan. Here we go, Fukushima. Now this is a special low light video camera. So this is not providing static images. In this one, we should see quadrantids whiz through the sky. It does actually look like they've got a bit of cloud there now, but they are hopeful that the clouds are going to clear, and that they're using a fairly new type of consumer camera. It's like this. It's the Sony A7S. And it's ultra sensitive. That's what the S stands for. And they can set very high ISO rates with this and get live video of these very faint objects. We actually use one of these in one of our best ever shows showing the aurora, the northern lights, and it was spectacular.
Well, that's great to know, Paul, because that gives hope to everybody, doesn't it?
Indeed. I mean, we should see. You know, we specifically gone out to our partners in Hawaii and in Japan because this, as I said, the peak of the shower is only 3 hours long. So to see it, that occurs at a certain time of day, which is now. You have to go somewhere where it's dark. And that at the moment is Asia and parts of the Pacific. So hence why we've gone to our partners over at the Weather News in Japan.
So this is the peak at the moment, and you say it should last about 3 hours, which is the length of our
Yeah.
program. So during the peak, if all goes well, how many meteors should we see per hour, in your opinion?
Well, that's so difficult to tell because I haven't used this particular feed before. So they have different sensitivities. But if you were seeing this shower visually under very clear skies with what's
Hmm.
called the radiant, fairly high overhead, there's this thing called zenith or hourly rate. And that's the perfect conditions, moonless skies, if the radiant, in other words, where the meteors are appearing from, is directly overhead. The quadrantids usually produce between 60 and 120 meteors per
Oh,
hour.
beautiful,
So
beautiful.
it can basically eclipse some of the better known showers, but because it's only over this very short period of time, very few people in history have actually managed to observe the peak of the quadrantids.
And one of the differences between this meteor shower and, say, the Geminids is we were battling the moon last time out, weren't we?
We were. I mean, the moon is possibly the biggest killer of meteor showers. Having said that, we still picked up some incredibly bright Geminids. We've got a whole variety. In fact, Bob Berman will be telling us a little bit later about some of the meteor showers that we've got to look forward to during 2017, because we've got some good ones coming up where the moon is not going to impact very heavily at all.
Well, you brought it up. This is going to be a big year for Slooh, isn't it?
It is indeed, yes. Oh, we've got some big plans. I mean, it already has been. I mean, frankly, 2016, ended with a bang, literally a cosmic bang. A Slooh member, Emmanuel Conseil, discovered a nova with the Slooh telescopes in the Canary Islands. I mean, what a wonderful way. There it is, actually, in the
There it is right
Andromeda
there.
Galaxy.
Wow.
So,
Wow.
and one of those tiny, tiny white dots is the nova that he discovered. And would you believe, only a year before, in 2015, on Christmas Day, he discovered another nova in the Triangulum galaxy, one of my very favorite galaxies. So that was the Christmas Day nova, but then he followed it up with this one as well. Absolutely
Well,
extraordinary.
this guy's a superstar. Does he get anything for it?
The kudos of having his name
Come on. He should get
associated to
like a
it,
new
but
car or something.
exactly. I mean, some kind of prize. I mean, just a small cup or trophy, or maybe a badge or something. But
Yeah, yeah.
unfortunately, it is kudos. And actually, Emmanuel does this not for the pure discovery, although he does enjoy that. But it's actually the science. It's all of the observations after a nova or supernova help scientists and astronomers to understand the physics of what's going on in these sometimes cataclysmic explosions.
All right. Well, the Quadrantids underway. The peak is underway, and we're holding our breath and crossing our fingers. Paul, it sounds like it should be a great show. We can't do it without you, so we'll check back with you very, very soon. As you can tell, we've
See you
got a
later.
packed show for you, but it can't be all about us. You can join in on the fun on social media. Send us your questions, notify us of your own meteor sightings, and let us know where you're watching by tweeting to @Slooh on Twitter or by joining in the live chat on Facebook. This is truly a global show, so let us know where you're watching from. We'll read some of those responses on the air later. Coming up here on the show, I'll be joined by astronomy journalist and author Bob Berman, who will tell us all about this fascinating but brief meteor shower. And a bit later on, I'll be talking to Helen Avery, Slooh's human spirit correspondent, who will tell us why comets have been harbingers of doom through the years. So please stay right where you are. This February, a ring of fire will rise over planet Earth. Millions will be plunged into the moon's shadow as it races across the planet at supersonic speeds. The annular eclipse will make its way across South America, through Chile and Argentina, before crossing the Atlantic Ocean, making landfall in Africa, casting Angola, the Democratic Republic of the Congo, and Zambia into shadow. On February 26th, explore an eclipse like you never have before. Be a part of this worldwide event, right here on Slooh. Space for everyone. And we welcome you back to our coverage of the Quadrantid meteor shower here on Slooh, Space for Everyone. I'm Jerry Montour. Keep your eyes on the screen here because meteors can happen at any moment and they are very, very quick. Now let's turn to astronomy author and journalist Bob Berman. Yes, indeed, the man who always wanted to be Admiral of the Galaxy. It hasn't worked out that way yet, but there's still time. Bob, welcome. Happy New Year.
Thanks. Thank you, Jerry. Same to you.
My pleasure. 2003 EH1. We mentioned it at the top of the show. What is it, in your opinion?
Well, that's a good question. We never knew what the source was for the quadrantids. Normally, they're bits of debris from a comet. It is the case for our Halley's Comet meteors and for several others, Temple-Tuttle, Swift-Tuttle. We've got all sorts of meteor showers that have very well-known comets that are the source, the parent body. But this one we didn't know until 2003 when Peter Jenniskens, who I think is the greatest meteor expert in the world. I spent some time with him back when I was with Discover magazine. And he found this body, 2003 EH, that moves in the same path as the Quadrantid. So this is the parent body, probably an asteroid, but the problem then is asteroids don't really shed material to produce meteor showers, but maybe it's a has-been comet. It was a comet, it's lost most of its material, and now it's just the core that's remained, and we call it an asteroid. In any case, okay. 2003 EH. It's like more like a license plate than a celestial body.
I thought it was like an old Toyota. But why is it, Bob, that we don't know exactly what it is?
Well, because comets are very clear. As we know, they have comas, they have tails, they have. They're very distinctive. And asteroids are also pretty clear as being just point-like objects. Even the largest Ceres, you'd have a hard time seeing anything but a dot of light, even through a large telescope, whereas comets are spread out, they're millions of miles long. The tails are when they get near the sun. And yet here, this object does not have a tail, and yet it seems to be the source of these meteors. So a little bit of a mystery. Mysteries are nice.
They are, but they're also incredibly maddening, in my opinion. All right, now this particular meteor shower, I guess, as all meteor showers are, they're predictable in one sense of the word, but also unpredictable. Predictable because we know basically when they're going to happen on what nights, but unpredictable because we just don't know how intense they're going to be. Correct?
Right. There's something that all meteor showers sort of have in common. We know that the Geminids. The night of every year on December 13th to 14th are going to put on a good rich show with 1 to 2 a minute. We know the Perseids on August 11th and 12th will do the same thing. But sometimes they have many more than normal. Sometimes they are a little disappointing. The Quadrantids are special because they're so brief. They only come to maximum, and within about 3-4 hours of maximum, as you pointed out a little while ago. Right now, that means during the next few hours. This is when they're at their peak. And when you catch them not at their peak, if you're just 6 hours too early or too late, they're pretty skimpy. So because of that, fewer people see them.
What is your personal opinion of meteor showers? I mean, everybody has their own idea of. Do you like them? Do you anticipate them? Do you look forward to them, or are they just another meteor shower as far as you're concerned?
Well, shooting stars, people talk about making a wish. There's something about them. I don't know. They touch the spirit. I've been watching our astronomy groups watch them. I like watching the people who watch the meteors, and they always make people gasp and go, "Oh, and look at that," and "Oh my God." And so why should a little streak of light in the sky that lasts for a second or two, why should that do that to people? There's no rational reason for it. They don't usually have color. They can be green or yellow, but they're not a rainbow of colors. There's no real rational reason why it should produce the effect that it does, why all people react so viscerally and predictably to them. A bright fireball, that is a truly bright meteor that can cast shadows, a bolide that is an exploding meteor, okay, you can understand that because it looks like real fireworks. But a normal meteor going across the sky, why does it do that? And yet it does. So we have to deal with reality, and that is this, people react to it. It's a visceral, gorgeous thing, our meteors. And
I can tell
so
you
we go
why
out of our
I
way to
love
see
them,
them.
and that is it seems to me like when I see a meteor across the sky, it's like the sky has come alive.
Well, you make a good point because the rest of the sky is stationary. The relationship between Orion and Gemini above it and the dog star to its lower left, that never changes, not in 100 years, not in a
Hmm.
thousand. And here you have a meteor, which is a sudden, very dramatic change. Even the brightness of a meteor changes as the meteor moves across the sky. It can suddenly get much brighter for a fraction of a second and then dim down again. So this sudden dramatic change, this animation, is in sharp contrast to what most of observational astronomy is. So, yeah, I think perhaps it's that produces the emotional reaction in people.
You live in upstate New York, Bob, and I know there's not a lot of light pollution there, if any. Uh, I assume that's one of the reasons you live there. And how often do you go outside to enjoy the night sky?
Well, yeah, pretty often we've got a meadow behind the house with the better part of an acre that clear skies, and we see the skies are as dark. We've measured them as dark as many of the darker sites around the world. The observatory we have here is 17 miles away. That's fairly dark, not as dark a place as this is. And I love naked eye astronomy. As you know, I lead groups every year all around the world. We go to the Atacama Desert and to other
Mm.
places just to get into dark skies. And yes, we use giant telescopes and observatories, but naked eye astronomy, the things you don't need any equipment for, a total eclipse of the sun, the aurora borealis, great meteor shower, a bright comet that comes along every 15 or 20 years. I think these are among the best sights in the sky. And the Slooh, of course, brings these things to everybody. We're not using views through a telescope. I mean, Saturn through the Slooh telescopes is still astonishing, and Jupiter and that kind of thing. But look, here we have a view of the entire sky. We're looking at it from the mountaintop in Hawaii, and no magnification is required. And there's something very, I don't know, basic and beautiful about this type of astronomy that doesn't need any fancy equipment.
Well, naked eye astronomy also brings the quote unquote everyman into the equation, correct?
That's right. Unless you really have really truly bad eyesight,
Right.
absolutely anybody can participate. The price is right. Uh,
Yeah.
Meteors don't cost a dime to see, and it takes us out of ourselves, doesn't it? Especially after a dispiriting election year like the one that we've had. It doesn't matter your political views. This was kind of draining, and politics and earthly problems, astronomy and Slooh just takes us all away and gives us a broader perspective, a deeper view of what's real. So sure, who could fail to love this stuff?
Absolutely, absolutely. Of course, this particular meteor shower is a bit tough for, well, those of us in particular. You and I are both in the northeast of the United States, so getting out in your backyard deep in the night is a little difficult.
Yeah. And those of us who live in rural regions, of course, have the sky a view close to what we're looking at right now on the screen as we wait for the next meteor here of the Quadrantids. I also love the fact that the Quadrantids were named for a constellation that doesn't exist anymore. When we talk about the Perseids or the Geminids, well, that means belonging to Perseus, the constellation Perseus, or belonging to Gemini. There are the Leonids. They're all named for constellations. Where is Quadrantid? That we have this quadrantid meteor shower. It turns out it's one of those constellations that didn't exist until about 250 years ago. It was created by a French astronomer, Lalande, the famous Jerome Lalande. And then in 1929, when the World's Astronomy Group, the IAU, decided which constellations were going to disappear. This was one of them. So a quadrantid, quadrants, the constellation was called Quadrans Muralis. A quadrant is an instrument like a sextant, an octant, a quadrant used to measure angles in the sky. And so Quadrans Muralis was axed. It no longer exists. And yet these meteors that stream from that part of the sky where the constellation used to be, we still call it the Quadrantids. I love that. It's like a throwback to centuries ago. Right near the end of the Big Dipper, the star Eta Ursa Majoris, that's where Quadrantids used to be. The brightest star near there is Arcturus in the constellation of Boötes. So it's great. This ties in history, ties in old stuff and new stuff.
Bob, we're having a little trouble with your audio, so we're gonna wrap things up with you for the time being. But please don't stray too far. Thanks for the info. Don't go away. We'll check back with you shortly. And coming up here on the show, Paul Cox is back to take a closer look at our live feeds. And later on, I'll be talking to our human spirit correspondent, Helen Avery, about the fascinating reactions to these meteors. And it ain't always pretty, so please stay tuned. We're excited to announce the release of our first book, The Saturn Above It, an anthology of short fiction about space. Available now at slooh.com.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
All steps for man, one giant leap for mankind.
And welcome back, everybody, to our live coverage of the 2017 Quadrantid Meteor Shower. I'm Jerry Monteur, your expedition leader here at Slooh, Space for Everyone. We are watching our global live feeds, hoping to soon catch a glimpse of some of these bits of fiery space debris as they intend to streak past the lenses of our low-light cameras. We've got our fingers crossed. Before we move on, here's a quick shout out to Mike and his 5-year-old daughter, Emma, who are online and watching our show in Liverpool. That is Liverpool in the UK. And here to talk more about our live feeds and so much more is our friend Paul Cox, Slooh astronomer. Paul, if and when we see these meteors, are we expecting to see the kind of meteors? Is there any that we've seen before? Is there anything different about the way these meteors will look?
They are, quadrantids are a little bit slower. They're kind of a medium pace meteor, so not quite as fast as some of the ones that we were seeing last year with the Perseids and the Geminids and things like that. But, you know, it's relative. You know, I mean, these things are moving at something like 90,000 miles per hour. I mean, so it's a matter of degrees, isn't it? But, you know, we are very hopeful that things are going to pick up. This is the Mauna Kea static image. So this is a feed, a constant stream of individual images that are going up using this particular camera. So we are expecting to see streaks emanating from the top left of that feed, and they'll stay there until the next image updates. But I have heard from our partners Weather News in Japan that they are anticipating the clouds are going to be clearing for the Fukushima feed. So this is the live video feed using a very special low light video camera, and they're also hopeful that their second video feed is going to be coming online a little bit later too. So cross fingers. You know, we all know meteor showers, you need a little bit of patience for them, but we are guaranteed to see something this evening, Jerry.
And Paul, just for the uneducated out there, which might include me, why are we hooking up with observatories in Japan and Hawaii? Simply because of the time of day?
Exactly. This particular peak, the Quadrantid meteor shower, has this very narrow 3-hour peak of activity. Observe it outside of those hours and you don't see very much at all. That 3-hour period started when our show started. So you have to go somewhere in the world where it's dark. And our Canary Islands Observatory at the Institute of Astrophysics of the Canary Islands, that's where the telescopes are that Slooh members use every night. It's daytime still there. It's daytime here in the UK. I'm in the same time zone. So that's why we've had to hop over to the Pacific for this particular show.
Well, for everyone's sake, including young Emma, who is watching with her dad, Mike, in Liverpool, we certainly hope for a good show and soon. Well, while we got you here, Paul, let's chat a bit about what's coming up, courtesy of Slooh this year. It's a big eclipse year, isn't it?
It's a huge eclipse year for us. Not least, actually, the one that I'm kind of looking forward to almost more than the major event is the one that's coming up next month, the February annular solar eclipse. This is where, you know, it's not a total solar eclipse. We see still a ring of the sun behind the moon, and we're going to be covering that. In fact, viewers saw the promotion for that. So we'll be able to see that as it passes across Chile and Argentina, then it whizzes across the Atlantic Ocean. And it's quite possible that you and I might be going to Angola, of all places, to view that one. But the major event, obviously, is late summer. It's the transcontinental solar eclipse. This solar eclipse that's crossing the entire continental United States has got to be, it will be the most viewed solar eclipse in history. I can't ever remember a solar eclipse that has moved over an area so completely, which is so heavily populated. We've got a very special show lined up for that one, and a very special location to be broadcasting from as well. So yeah, pretty cool eclipses this year. Unfortunately, lunar eclipses this year aren't that great, but I'll tell you, those 2 solar eclipses are going to make up for all of that. And in fact, Jerry, we've got our new solar telescope as well, and we're going to be able to use that, would you believe, for this annular eclipse. Now, we know that, you know, the path of annularity, where the shadow goes, is far south, but we'll just see through the solar telescope at the Canary Islands Observatory a little bite taken out of the moon, taken out of the sun, using our new solar telescope. So that's going to be fun as well.
And speaking of eclipses and equipment, you really want to hit the Slooh store, especially because of these eclipses. Yeah, no question about it.
Yeah, and yeah, talking of those eclipses, we've got it's a limited edition, and you know, we're not kind of forcing people on this as a sale at all, but these glasses are superb. They're special eclipse glasses, and I actually bought some to do the Kenya eclipse a couple of years ago, and I also used them in Indonesia in 2016. The frames of them, Jerry, are like normal sunglasses, but they have this special material in them, just like the cardboard eclipse glasses do. But anybody who's used the cardboard ones, you know, they're a little bit uncomfortable. They kind of flop off your ears. Having the Slooh limited edition eclipse glasses, they are limited edition, so I would highly recommend it if anybody's going to go to the USA in August and view that eclipse. Grab a pair of these.
Course,
they can buy those
view the eclipse
website.
at your own risk, right? But we encourage you to check out these glasses.
Absolutely, yeah.
So again, the major difference between the August eclipse that you referred to and others throughout the years and the millennia is the path it takes. Is that correct?
That's right. I mean, the shadow of the moon touches the ground, you know, on the west coast of the United States, and then just goes across, traveling incredibly speedy across the entire United States. So it's even visible for people on the East Coast as well. Now, everybody in the United States will get to see a partial solar eclipse. You have to be on this fairly narrow path of the totality shadow. It's about 70 miles wide, I believe. You have to be somewhere within that path to see a total solar eclipse. And really, there is
looks like we have lost Paul temporarily. All right, we're going to wrap things up with Paul, but we'll get him back on board in just a second. He'll be back several times throughout the show. Next time, talking about how we can hear meteors as well as see them. And coming up very soon here on the show, Helen Avery discusses how comets and meteor showers have, quite frankly, freaked people out through the years. And later, Bob Berman returns to tell us why meteor showers are just so fickle. So stay with us.
As we celebrate our 13th anniversary, we're excited to bring you the all-new Slooh.com with an all-new reservation system, brand new telescopes, and introducing Slooh Recommends. We're bringing the universe closer than ever before. Coming soon to Slooh, where there's space for everyone.
This February, a ring of fire will rise over planet Earth. Millions will be plunged into the moon's shadow as it races across the planet at supersonic speeds. The annular eclipse will make its way across South America, through Chile and Argentina, before crossing the Atlantic Ocean, making landfall in Africa, casting Angola, the Democratic Republic of the Congo, and Zambia into shadow. On February 26th, explore an eclipse like you never have before. Be a part of this worldwide event, right here on Slooh. Space for everyone. And we welcome you back to our Quadrantid meteor shower show here on Slooh, Space for everyone. I'm Jerry Monter. We got a terrific lineup of guests and, of course, our live feeds providing views of meteors just for you. We're awaiting our first, so keep your eyes on the screen. You know, through the years, people have been both fascinated and terrified by things they see up there. And we turn now to our human spirit correspondent, Helen Avery. Helen, welcome aboard. So we think comets and meteor showers are pretty cool, but not everyone has always agreed with that, have they?
No, no, absolutely not. Actually, the comets have been seen sort of as a kind of the end of nigh prophecy, dating as far back as we know, probably even before that, but certainly on record as the Babylonians, who associated comets with like the death of leaders and the death of kings and stuff like that. Yeah, the reason we think that is, we're not entirely sure, is simply because, you know, there was so much chaos in the daytime and the weather was unpredictable. But at night, when they looked up to the heavens, there was some order to be found. Like the stars were where they should be and they moved across the sky and the moon did what it was supposed to do. So when you had something arrive like a comet or even like a meteor shower, things were sort of seriously awry, would you say? That's what people thought. It sort of scared the bejesus out of them. Yes. So yeah, not always a good thing if you're back in the day.
So back then, the thought process was this was a message from the gods or something like that?
Yeah, yeah, it's sort of interesting how even sort of before modern religion, we were looking up to the heavens and thinking that they could do something to us and punish us all at any moment. It's very, very interesting. So, so the Greeks and Romans, they saw the sky as like a big dome, and that the stars were actually pierced holes in the dome and the gods lived beyond the dome, and the light that shone through that formed stars was actually the light from their fireplaces in their palaces. Which is just lovely to think about. And they thought that every time the gods got slightly annoyed with them, what they do is they take a bit of coal out of their fires and then push them through these holes and throw them down at Earth in the form of like meteor showers, to a lesser extent comets. But yeah, there was some sort of punishment from the gods taking place. And the Chinese were similarly very superstitious. They associated comets with war and pestilence, famine, all those things that can really ruin your day as a human being.
That would ruin my day. So how frequent are comets?
It really depends. There are different types of comets. So some comets are short period comets and they can range from like 3 to 7 years, their orbit. And then there are like Halley's comets, which are sort of more like 28 to 76, and Halley's comet is a 76-year orbit comet. And then there are the really long period comets like Hale-Bopp that was with us fairly recently, and that orbit goes right out to the edge of the sun's kingdom in the Oort cloud, where that orbit takes it, and that's something like 2,300, a little more than that, years for that orbit to take place. So it can really depend, but they're very common. We just don't often see them with the naked eye. So I guess when we do, humans are like, oh my God, what the hell is happening here?
So when people got freaked out back in the day, did they have good reason? In other words, have there been any examples of where comets have actually brought doom as predicted?
Right. It's a good question. And I guess, you know, in any given year, bad things happen. Is it just coincidence that they happen when there's a comet in the sky? I mean, so Halley's Comet is the one, because it's every 76 years, that we have a lot of records for over history. And there is a record in, I think it's like around 280 AD, I can't remember exactly the year, that Halley's Comet was in existence. And the records in China say that that year with Halley's Comet, there was a huge drought, and an empress died and a general died. And then we have other records of a Halley's Comet appearing in, I think, 680 or 650 AD. And that year, I think that was in Germany, the records where there was a huge storms and, again, a famine. And then the most famous, perhaps, for Halley's Comet was in 1066. So we have that depicted, Halley's Comet, on the Bayeux Tapestry. And in that year, things really went down, particularly for my ancestors, because King Harold was killed in the Battle of Hastings. And William the Conqueror came over to Britain and invaded. It was the Norman conquest. So I guess it depends, if you're Harold the Comet that year was bringing doom, and if you were William the Conqueror, I guess it was a good thing. But it's the most interesting thing, I think, is that even recently, we still, as humans, even though we understand what a comet is now, still kind of have this feeling that there's like an omen when a comet's around. So Halley's Comet was last with us in 1985, 86. And there was a lot of literature being dispensed at that time that was like the end of the world is nigh. And if you look with hindsight at what happened, the period that Halley's Comet was with us, you could kind of say it was a bad period. There was the Libyan hijacking of Pan Am Flight 73. If you remember, and I remember I was about 8 at the time, it was really where the AIDS crisis was really beginning to sort of take hold. Band Aid or Live Aid was that year because there was a huge famine in Ethiopia. And then, I don't know if you remember this, but there was a huge soccer riot in a stadium in Brussels, and 600 people injured.
Of course, yeah.
And 39 people died that year. So a lot of people blamed that on Halley's Comet. But as I said, in any given year, horrible things happen, unfortunately. So when comets aren't around.
But isn't it incredible to you, Helen, that that's still taking place, that people are still blaming celestial events on bad news?
I know, it's so funny. I mean, even for the non-religious of us to still think that we are at the mercy of something beyond our control that could at any moment just sort of do something to us and obliterate us, which really, good, if a big enough meteor comes our way, I guess.
Yeah, I suppose that could happen. Sure.
Yeah. But fortunately for us, no comets that we're looking at today, just meteors.
Yeah, right. So I think it's kind of interesting that it's still deep in our consciousness. I mean, here we are looking into the night sky, as you can see right there, seeing what could be the debris of some ancient comet that was terrifying humans back in the day.
Right. I know. It's kind of wondrous to think we have this connection still, when every time we look up in the sky we can connect back. Admittedly, we're connecting back to some fear. Maybe that's just in our collective conscious now. Whenever we see a comet, it's in our DNA, who knows. But yeah, it's sort of lovely to have this sort of chance to connect through history by looking at the sky.
But now we know that comets are just collections of ice, rocks, and dust, etc., right?
It's true. I mean, really, it's like the epitome of what a lot of fuss about nothing, really. And there's this wonderful quote. Let me see if I cut it out because it was so good. Here it is. It's Dr. Krupp. He's an astronomer, and he explains that a comet tail as big as the Pacific Ocean, packed well, could fit into a suitcase, because they're just made up of dust and ice and particles and gas. And although they have this sort of huge tail on them, and comet means like hairy, so it's like this head with this hairy tail that can be 100 million miles long. Actually, they're kind of, there's nothing really there.
So nothing to be afraid of, nothing to see. Go on home. Take it easy, relax.
It's true.
All right, Helen, thank you so much. We're keeping our eyes on the skies and on the screen. Helen will be back in just a little while to talk about the origin of this particular meteor shower. Helen, appreciate it. All right, coming up, Paul is back to explain how you can hear meteors as well as see them. And later, Bob Berman returns to offer some insight into the who's, what's, whys, and wherefores of meteor showers. So stay right there. We're excited to announce the release of our first book, The Saturn Above It, an anthology of short fiction about space. Available now at slooh.com.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard.
Small step for man, one giant leap for mankind.
And we welcome you back to our live coverage of the 2017 Quadrantid meteor shower. I'm Jerry Montour, your expedition leader here at Slooh. We're watching our global live feeds, hoping to catch a glimpse of a meteor or two, or 50 or 60. But even if we couldn't see them, we could hear them. And here to tell us how that's possible is our friend and Slooh astronomer Paul Cox. Paul, before we talk about that, we've got feeds from Japan and Hawaii. Talk us through that, will you please? All right, we're having trouble hearing Paul once again. We've got issues, please, issues. All right, again, we are keeping an eye on the 2017 Quadrantid meteor shower.
I've got some feedback. Can you hear me?
Oh, yes, Paul, we've got you now.
Okay,
So,
sorry, I had a bit of feedback there. Yes, this is a new feed that's come up from a lovely chap in Nara, Japan, called Hosekan. And you can see here, this is a live video stream. And just to the left of us, you can see that magical constellation of Orion, probably the most recognizable constellation in the night sky. And I know a lot of viewers have also been seeing that and pointing that out in the Mauna Kea feed. Now that feed is coming from high on Mauna Kea, the volcano in Hawaii. But we're quite hopeful that we're going to see some streaks coming through here. The Fukushima feed that we've got in Japan, that is still clouded out, but the guys there are telling me they are still hopeful. So we've got a brand new feed up. So let's cross fingers, and we're looking through the clouds here. So that's pretty cool. But as you said, Jerry, sometimes you can observe meteors even when it's cloudy, or even in the day.
yes, and not necessarily by sight. You can also hear them. What the heck is that all about?
That's right. Well, it's radio meteor detection. And the thing I love about this is anybody can do it. You can, if you've got a kind of old-fashioned VHF radio receiver, an FM radio receiver, basically, you can do it. Now you can get very, very advanced with it and buy all sorts of extra equipment and special aerials and stuff like that. But at its basic, this is what's happening. Now, if you imagine, I'm in the UK now, it's still daylight outside, but there are Quadrantid meteors up there. But of course, the sky is too bright to actually see them. So what happens is one of these tiny, tiny specks, a meteoroid, burns up in the atmosphere. It basically vaporizes. And sometimes that burning up and that vaporizing will leave a small trail or train. And that's ionized gas. The gas has been so excited by this almighty collision of this tiny speck that it kind of loses electrons and gets highly energetic. Now, if you can imagine that trail as something physical, it actually reflects radio waves. And it will reflect the radio waves of even a local radio station. So what you need to do, this is so easy. This is at its real basics, right? You tune your radio, you look up on the internet the frequency of a radio station that you can't get at your house. So maybe one in the next county or the next state, right? 50 to 100 miles away, something like that. And you tune to that frequency. So don't forget, radio needs line of sight. So they're kind of 50 to 100 miles. They're too far over the horizon for you to pick up their station. But because that trail is right up there, the radio station from that, the radio signal from the radio station reflects off that meteor trail and comes down to your receiver on that particular frequency. Now, as I say, you can do all sorts of fancy things and get fancy receivers and big antenna and aerials and stuff like this. But that's at its basics, that anyone can do it. Now, we'll have a look on screen again. What we tend to do with this, you can hear it as an audible noise, but we feed that noise into a little bit of free software. And actually, I'll post the free software in the Slooh Clubhouse where members hang out later on.
Good.
And you turn it into this visual representation. So what we're looking for there, Jerry, is a short, bright line. And that's, there you go, as if by magic, there is a quadrantid meteor.
All right. So for the scientists out there and the ones that do have the fancy equipment, what good is this? Is this a way to count meteors?
It's a way of counting them, but unfortunately with radio detection, unlike the visual camera networks that are set up, you've got the UK monitoring network, they can triangulate their visual observations. But with radio detection, that's a lot more difficult to do. So it's not as accurate, but yes, it is a way of measuring the number. And especially with a shower like the Quadrantids, it will show when the peak is. So they can see the distribution of meteors over a longer period of time. And of course, most meteors have a fairly long period of time, days, sometimes weeks, where the shower's weak and then goes progressively further and further up to its peak. So it's a very good method of doing that, Jerry.
Paul, does a stronger or louder audio signal mean the meteor is closer?
No, because they tend to, they're so high up in the atmosphere. You know, these things are 80 kilometers up, 80 to 120 kilometers altitude. So they're really all quite far away. But it's the size of them does get reflected in how much noise we hear from that reflected signal, and also the strength of the line that we see on the visualization as well. Basically, because there's more material that's burnt up, vaporized, and it's ionized more gas, therefore there's a larger area to be reflected down to your FM radio set.
All right, so we're hearing them at the moment. We can't wait to start seeing them as we're in the middle of the peak. And while we wait for that, Paul, I know you don't like to toot your own horn too much, but this is a pretty big year for you too. I mean, you're going everywhere, aren't you?
Yeah, I've got a bit of a, the beginning of the year is pretty packed. We've been invited, Slooh's been invited to make a presentation to the American Astronomical Society winter meeting. That's going to be quite good fun. Now, we're talking about the Slooh Classroom project there, which we're very, very excited about. Then, of course, I'm on to our Chile observatory, where I'm going to be installing some new equipment for members to use every night. So that's going to be pretty cool.
Now we're talking. All right.
Yeah, absolutely. And it's a cool telescope as well. It really suits my particular interest. I love planetary observing. Jupiter's my favorite object in the night sky. It's so dynamic. And this new telescope in Chile is going to be taking live video. So a live video stream of the planets and the moon. But then I'm hopping over to HQ, Slooh HQ in Connecticut, to help the guys out there put the finishing touches to the all new Slooh, which we've seen a promo for actually, but Jerry, it is looking absolutely fabulous. And then I'm over to the Canary Islands Observatory. Hey, look at that large meteor there. Woo. Now, that might not be a meteor. We'll come on to that in a second there, Jerry. But hopping back over to the Canary Islands Observatory at the Institute of Astrophysics of the Canary Islands, once again, to bring not one, but several new telescopes online for members to use every night. Now, look at that long streak, Jerry. Now, we know that a meteor is not going to be lasting that long. But if you can imagine, there are other objects in the sky that can reflect that radio signal. That, my guess would be, is probably an aircraft. So it's providing an almost constant reflection of that radio signal. So that's probably an aircraft going through. And in fact, people do confuse aircraft with meteors sometimes in the sky as well.
So all these trips you're taking, Paul, you get frequent flyer miles for this?
I don't, I'm afraid. You know, it's coach class. In fact, sometimes
My
I'm in the
friend.
hold. So no, it's
You
they're
disappoint
kind of
me.
exciting. They're exciting trips, but you know, I never get to actually see the places that I go. I don't ever have time to kind of see. Yeah, I'm working solid, and these observatories, you know, they're far away from towns or any kind of social life or anything like that. So it's very much head down. You're working nights most of the time anyway. But yeah, I'm not complaining. It's fun.
Well, you're a workaholic, and you're an inspiration to us all here at Slooh, Paul.
Well, thank you.
All right, now back to the meteor shower itself. Again, let's walk through it for the viewers who are just perhaps tuning in. Again, this is the Quadrantid, and it is peaking at as we speak, right?
We are actually in the middle of the peak period. So yeah, we are very hopeful on this particular feed, this feed coming in from Hosokan in Nara, Japan. And yeah, we're pretty damn hopeful on that one. Patience is always required. You know, even with, I think Bob hinted at it earlier, that even a forecast like this, that this is going to be the peak time, it's only a forecast. So the peak this year might only occur for 30 minutes. So all of those meteors that we were expecting to see might be condensed within a very, very short period of time. It might be at the end of it. It might be at the beginning. You know, and this is really what's one of the exciting things about a meteor shower, actually. You never know when it's going to happen. And you said earlier that I think it was Mike is watching with his daughter Emma from Liverpool in the UK. Keep watching. And one of my personal best experiences of a meteor shower was observing the Geminids with my daughter when she was 5 or 6. It was a magical night just because we were seeing plenty of meteors. She'd never seen anything like it before. And that kind of amplified my enjoyment of that particular meteor shower kind of tenfold. You know, it's the same whenever we hear from, you know, viewers who are watching with their kids. It always makes the effort worthwhile when we know they're enjoying it.
Absolutely. We cannot afford to take our eyes off the screen. All right. Thank you, Paul. We'll see you back in just a little bit. And coming up, Bob Berman returns to offer some more insight into this meteor shower. And later, Paul will be back to teach us how to snap some meteor photographs. So please do yourself a favor and stay with us. This February, a ring of fire will rise over planet Earth. Millions will be plunged. The annular eclipse will make its way across South America, through Chile and Argentina, before crossing the Atlantic Ocean, making landfall in Africa, casting Angola, the Democratic Republic of the Congo, and Zambia into shadow. On February 26th, explore an eclipse like you never have before. Be a part of this worldwide event, right here on Slooh. Space for everyone.
As we celebrate our 13th anniversary, we're excited to bring you the all-new Slooh.com with an all-new reservation system, brand new telescopes, and introducing Slooh Recommends. We're bringing the universe closer than ever before. Coming soon to Slooh, where there's space for everyone.
And welcome back to the Quadrantid Meteor Shower show here on Slooh. Space for everyone. I'm Jerry Montour, and we continue to scan the skies along with you, ever hopeful. Now let's turn back to astronomy author and journalist Bob Berman. And Bob, welcome back to the program. As I mentioned, you've got to be hopeful. You've got to be vigilant when it comes to meteor showers, don't you?
Yes, of course. And the surprise is one of the great things about it. We were talking about that before, that there's the static background sky unchanged since pre-biblical times. And then suddenly, wham, there's this dramatic change in the sky. So it's part of the allure. In fact, it's maybe the main part of the allure of shooting stars.
And when it comes to the quadrantids in particular, the peak is so brief, you really can't afford to take your eyes off the skies.
It's really true. And, you know, there's a parallel there. There's a sort of a metaphor for the shower itself. We started talking about that before and then went on to something else. But the quadrantids, people won't be criticized for saying, what the heck does that mean? What's a quadrantid? We know that the Orionids come from the constellation Orion. The Leonids are meteors that stream away from Leo, the lion in the sky. The Perseids from Perseus. The Geminids from Gemini. So the quadrantids are from what? And it turns out there was a constellation called Quadrans Muralis based on a quadrant. There was a time a few centuries ago when the sky new constellations were named for the gadgets of the time. A quadrant, you know, like a sextant, an octant, an old-fashioned instrument for measuring angles. There's telescopium and microscopium as constellations. Never a good idea. It would be like us setting up constellations like iPhonium in the sky. These rarely last very long or stand the test of time, but nonetheless, there was a Quadrans Muralis. And then in 1929, the IAU, the International Astronomical Union, said, no, we're going to get rid of this constellation. It was created by Jerome Lalande, famous French astronomer centuries earlier. We're going to get rid of this. We're going to get rid of the old ship Argo Navis that took up much of the southern sky. We're going to have only 88 constellations, and some of them that got the axe included this one. But here's the weird, fascinating thing. The meteors that have been observed streaming from the spot of the constellation kept the name. We always name meteor showers from the constellation's Latin possessive form from where they come from. So Orion becomes Orionids, meaning of Orion, pertaining, possessed by Orion. So these were the quadrantids, and we still call it that, even though there is no such constellation anymore. So it's not just we're looking at meteors and who knows what moment they're going to spring up, but we're looking at a part of the sky that doesn't really exist anymore.
Bob, how did they come up with that number, 88 constellations?
Yeah, same number as keys on in a piano. Well, some of them were no-brainers. You couldn't do away with the classic mythological forms, mostly from the ancient Greeks, Perseus and Pegasus and Andromeda, and the legends that came from that. We couldn't do away with the zodiacal constellations, Aries, Leo, Gemini, made famous by their nefarious connection with astrology, and the bright constellations such as Orion. Of course, we're not going to touch that one. Scorpius, gorgeous. So these were just a few of the more obscure ones. And it was a council, done by council. The IAU is the international body, the only one that is authorized to tell you what names objects have, what names a new galaxy discovered will have. And so they're the ones. They first met in 1922, and by 1930 they made it official. And Quadrans Muralis, finished, no more.
Oh,
But the
sad.
meteors still exist.
So as we look at the skies, courtesy of our live feed from Japan, we'll be going back and forth from Japan to Hawaii, bringing you the Quadrantid meteor shower. Bob, do you think we'll ever encounter in our lifetime new meteor showers?
They're very slow in coming and going. Peter Jenniskens, who is the expert who discovered the source of these meteors, told me some time ago about how meteor showers, like the Perseids, the beloved summer meteors that we see every August 11th, they're going away because bits of material, most of them only the size of grains of sand, and at most apple seed sized bits of meteoroidal material, slowly spirals inward toward the sun to be swallowed up by the sun, thanks to the pressure of sunlight, something called the Poynting-Robertson effect. Love that kind of talk. Makes meteoroids lose energy and they get swallowed up by the sun. So they're leaving us, they're falling away from Earth's orbit and going closer to the sun. While the Geminids, the beloved Geminids, every December 13th and 14th, they're just on the outer skirts of our orbit and they're moving inwards. So that'll be a better and better meteor shower in the decades and centuries to come. So Jerry, these things take centuries to develop. And if a new meteor shower comes, it could. They're mostly comet debris. The debris slowly moves inward to our orbit. We'd start noticing a few extra meteors beyond the background rate of 6 per hour, year after year, coming from the same section of sky. And year after year, they would slowly increase in number. This is what happens until finally we have to recognize, hey, this is a new meteor shower. And then maybe it would continue to richen until it becomes as good as some of these others that we watch at Slooh every year.
We mentioned before that the Quadrantids are caused by an object known as 2003 EH1. Are there other meteor showers out there that originate from strange things like that?
Yes, the Geminids come from an odd body called Phaethon. And that was also not discovered until only about 15, 20 years ago. Phaethon also looks like an asteroid more than a comet. It comes in beyond the orbit of Mercury. It's very uncomet-like. It has no comet-like tail, but it has a little tiny weird asteroid tail, which we didn't even know asteroids could have tails. So yeah, that's the only other one. All the rest of the meteor showers come from established comets, even Halley's Comet. 2 of the year's meteor showers come from Halley's Comet. One comes from Swift-Tuttle. One comes from Tempel-Tuttle. Tuttle, always named for the discoverer of the comet. In the case of Swift-Tuttle and Tuttle himself, these were Civil War astronomers. So sometimes the source of the meteors were discovered way back a century and a half ago. And sometimes they're newly discovered.
Bob, do you remember the first meteor shower that made an impression on you as a kid?
Well, no, actually, meteors are always dramatic. They always make people gasp, including myself. You go, like that. And I've been watching them, of course, since I was a kid in summer camp. I remember how the counselors, because I knew the sky, I knew the names of the constellations. And so they had me lead the group when I was 12 or 13 years old. Loved it every year at summer camp. And it was certainly a special part of the summer, the August meteors. And I'll bet a lot of people, maybe most people, have memories dating back to childhood or summer camp or vacations with their family. How about yourself?
Well, talk about making an impression. Yeah, it was August for me. And I think I was about 8 or 9 years old. And I think that's the first time that I really took notice. That's the first time the sky really came alive for me. All right, Bob, we're going to take a break. And we'll check back with you shortly. Coming up, Slooh astronomer Paul Cox is back to teach us how to take meteor shower photographs. And later, another of our Slooh astronomers, Eric Edelman, is here to give us his unique take on meteor showers. We'll be right back. We're excited to announce the release of our first book, The Saturn Above It, an anthology of short fiction about space. Available now at slooh.com. This February, a ring of fire will rise over planet Earth. Millions will be plunged into the moon's shadow as it races across the planet at supersonic speeds. The annular eclipse will make its way across South America, through Chile and Argentina, before crossing the Atlantic Ocean, making landfall in Africa, casting Angola, the Democratic Republic of the Congo, and Zambia into shadow. On February 26th, explore an eclipse like you never have before. Be a part of this worldwide event, right here on Slooh. Space for everyone. And welcome back, everybody, to our live coverage of the 2017 Quadrantid meteor shower. I'm Jerry Monteur. I'm your expedition leader here at Slooh, and we're watching our live global feeds from both Hawaii and Japan. This is one of our Japanese feeds here, streaming live meteors. We're in the middle of what is supposed to be the peak of this particular meteor shower, but maybe you want to capture some meteors using your own camera at home. Well, here to tell us how to do that is our friend Paul Cox, Slooh astronomer. Paul, you don't have to be a millionaire to make this happen, do you?
You don't, not any longer. You know, it's the same as most consumer electronics. You can cast an eye back to 10 years ago and this simply isn't possible. But now, my word, you can do it incredibly cheaply. But let me just point a couple of things out on this live feed, Jerry. So thankfully, the clouds did clear in Fukushima. And we can see there the constellation of Orion. You can just see Orion's belt just above the word Japan. Now, when we saw more of Orion, we were actually seeing the Orion Nebula. There were 3 stars that looked like stars, but they were actually the Orion Nebula. And he's not actually moving it because I've asked him. But then over to the right, we'll go back to that view a little bit later. We also saw the open star clusters, the Pleiades and the Hyades. So keep our eyes peeled on this view. This is our best chance of spotting a meteor. This is a live video stream. So how can people take any picture of a meteor from their own backyard? Well, we said it's cheap. And now, Jerry, is the perfect time to equip yourself. If you don't own a DSLR camera, that's a digital single lens reflex camera, now is the time to buy it. But I would not recommend people buying a new camera because there are so many fabulous deals on eBay. And you can take, with those cameras off eBay for 100, 150 bucks, you can take starscape photographs. So this is nighttime photography where you're capturing probably a beautiful building, maybe a church or a landscape with the night sky behind you. So 100, 150 bucks for one of those cameras. You can use actually just what's called the kit lens, the lens that comes with the camera. And you can take these amazing starscapes. Well, that's exactly the same process that you use to capture meteors. You just take very long exposures. Now, most of the best cameras, the ones that generate least noise on long exposures, were the early Canon DSLR cameras. And those are the ones that are cheapest at the moment. I'd recommend maybe a 450D, something like that. Really cheap, highly capable, low noise. You set it to a 30-second exposure. You set the ISO to probably 1600 or as high as it can go. You can experiment. The higher the ISO, the more sensitive it gets, but the more noise you get. And you must have that camera on a tripod. That's one of the essentials for this long exposure astrophotography. And you just keep going. I normally use a little bit of software actually hooked up to my laptop, and that's controlling the camera, and it's taking a long exposure image every 30 seconds. And
Paul, I also assume that you'd need a wide angle lens.
You don't want to go too wide. The wider you go, I usually would use something like a 35mm lens. That gives you a good field of view. But if you go too wide, if you start using fisheye lenses, the amount of light that they can gather goes down. So you'll miss the faint meteors. So I normally go kind of halfway in the middle, 35mm lens. And that's going to be the standard kit lens that comes with most of these digital cameras. But Jerry, there's something even better now. So if you're already a DSLR user and you feel like upgrading, and that's why actually this time of year there are so many secondhand DSLR cameras available on eBay, because people have just had a new camera, is this kind of camera. Now, these are really taking over from the DSLR cameras. This is a mirrorless, interchangeable lens camera. So you can still, remove the lens, put a different lens on it and stuff like that. But it doesn't have a mirror, it doesn't flick up. But this is a Sony A7S. This has revolutionized amateur astronomy. This thing is so sensitive because it has huge pixels on the chip inside the camera, which means they gather, lots of photons of light. And in fact, this is what we use for a lot of our Meteor cam video. So we use these as video cameras to spot meteors.
And a good ISO capability on that camera?
Oh, these things are crazy. I mean, it's over 100,000. They're crazy, but you do have to experiment with that a bit because it can get a bit noisy. But if people can't afford a DSLR camera or anything else, then actually go for an old action camera. You can get the Hero 4, the GoPro Hero 4 actually has a nightscape time-lapse setting in it. You can just pop this on anything. Of course, you don't need a tripod. You've got all the suckers and stuff like this for a camera like this. And you can just set it running and it will take continuously long exposures, very high sensitivity to light. And the camera itself will turn that into a beautiful time lapse. So you can see the stars and the planets and the constellations moving when you've finished taking them with that. So you can pick these up pretty cheap now as well.
All right, just want to make sure I've got all my notes here because I am a professional photographer. I want to sell these shots, okay? So you want a DSLR or a mirrorless, 35 millimeter, ISO 1600, and 30-second exposure. Did I get them all right?
Yes, you did. I would just say that you have to experiment with the ISO and the exposure setting. The thing that you're looking for there is that the sky background doesn't get too bright. So if the sky background is looking very, very blue, then probably either drop down the ISO or drop down the exposure time.
Also find a spot that has very little, if not zero, light pollution.
Absolutely, which is not that easy for the majority of people. I live in rural Somerset in England, and even out here in the countryside, with people's security lights and things like that, there aren't many places you can go now where there are dark skies, except, of course, the Canary Islands, which is where Slooh's observatory is, which is pretty cool.
All right, Paul, good stuff. All right, let's take another look here at our feed from Japan, one of them. You give me your impressions so far. I mean, we haven't seen a lot. We have heard a few things, though.
Yeah, I mean, this is the thing. We're still, well, we're a little 2 hours into the show. We have not seen as many as we were hoping, but it's exactly what I said earlier. The whole peak of this particular meteor shower can condense into a very short period of time. And when it does that, it stops becoming a meteor shower and starts becoming a meteor storm. And I saw one of those in the Canary Islands, and you literally did not know where to look. And there were so many meteors coming down. We all felt that we could sense the movement of the Earth in space. It really gave this sensation of the Earth flying through space. So this is where patience is key. And we've covered some meteor showers at Slooh where we hadn't seen a beam, but then another meteor shower, which we weren't anticipating was going to be very good, suddenly delivers the best show that any of us had ever seen. So a little bit of tenacity, a little bit of patience, and you've got to keep going, and if we don't see that many this time, we're still going to look at it next year, because chances are next year might be even better.
Paul, in your
optimist.
Considered opinion, why are they so unpredictable?
Well, if you imagine the objects that are leaving this trail of debris in space, comets, and in this case a kind of dead comet, an asteroid, those particles can actually, if you imagine, the comet's going through space, it can be active and not active. We've been watching, Slooh members every night at the moment have been watching Comet 45P, and we've seen the changes in the tail over a matter of minutes. Now, that material is blowing off the comet it's not uniform. It's coming off in chunks, and then there might be nothing. And then there's another huge kind of collapse or outgassing, with all the gas sublimating into space, pushing all the dust out. So this trail isn't uniform. You get dense clusters. And if there's a dense cluster where Earth is passing through that trail, then we're going to get a huge number of meteors. So the only way we can forecast these meteor showers is to look back at past showers and see when the peak goes. We can then model exactly where these streams of debris are, how dense those streams of debris are. But even then, all of that debris gets affected by other objects in the solar system, Jupiter being one of them, which perturbs that shower, dissipates over time, can pull it away from the path of Earth. That's why they're so unpredictable. In fact, meteor showers are as unpredictable as comets themselves are.
And it keeps driving us crazy. All right, Paul, thank you so much. We'll check back with you very soon, my friend. And coming up here on the summer, Eric Edelman will be here to talk about some of the basics of meteor showers. And later, Slooh's human spirit correspondent, Helen Avery, will be back to talk about the birthplace of this particular meteor shower. Stay tuned. We're excited to announce the release of our first book, The Saturn Above It, an anthology of short fiction about space. Available now at slooh.com.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard.
All step for man, one giant leap for mankind.
And welcome back to our coverage of the Quadrantid meteor shower here on Slooh, Space for Everyone. I'm Jerry Monteur. We've got a terrific lineup of guests. Of course, the real stars of the show are the meteors themselves. And with that in mind, we turn to Slooh astronomer Eric Edelman, who happens to be a show presenter at the Morrison Planetarium. Hi, Eric, at the California Academy of Sciences in San Francisco. And thanks for getting up at this, what is for you an ungodly hour, Eric.
Oh goodness, the sun is not yet up. It's 7 o'clock over here, which is not too bad. But yeah, it's great to be here to see what we have to see. Have you been seeing any decent meteors so far on the feeds?
Nothing yet, but we're ever hopeful. And as Paul mentioned a few minutes ago, what we're really hoping for now is not just a meteor shower, but a meteor storm, Eric.
Certainly, because with this unique shower, the quadrantids in particular, the peak can be so short, so fine, as opposed to, say, the Perseids or the Geminids, which their peak can last over a greater number of hours, even into days, so that people across the world, wherever they happen to be geographically, have more of a chance to see that peak, to see a lot of meteors at one point in time. Versus with this quadrantids here, it's very important where you are on Earth, because there's a particular period of time when those meteors are going to be so prominent, and it's best to be on a spot on Earth where the constellation that they appear to be emanating from, or the radiant, is really, really high in your night sky. So there's this whole delicate system of factors that have to come together. And if they do, goodness, it will be fun. Like, I've heard that there could be possibly, over 100 streaks per hour at a quadrantic peak at a really good time. So yeah, fingers crossed, it could certainly still happen.
Yeah, this is in many ways an underrated a meteor shower. Do you remember your first meteor shower, Eric?
My first meteor shower. So I'm one of those terrible people that was living in cities for most of my young life. So I was in places like Los Angeles, in San Francisco, in Hartford. I was just in places where there was a ton of light pollution. So I really didn't become very familiar with my night sky until a lot longer into my life. Actually, my first meteor shower that at least I can remember, was when I was in college. And I was actually starting to study astronomy. And so actually looking at the books was a way that convinced me to start to look up at the night sky. And actually, particularly for me, there was a bunch of us that were studying for finals near the Geminids. And so we were all in the same astronomy building. And then once in the middle of the night, when the Geminids were reaching their peak, we all sort of headed up to the roof to see the shower. And it was amazing to see it as this communal experience. I don't think a lot of us had seen meteor showers before. And so we were all sort of experiencing seeing those streaks of light for the first time. That being said, though, there's always that one person in the group where, in our case, they would always head right back down to the basement to study right when the streak was about to appear in the sky. So they would always be the one to miss it. You're always going to have that person in the group that's going to be looking away right when the streak appears. And it's so fun as a group to sort of trick that person, make fun of them, make sure that they expect that they've missed a lot more meteors than they actually missed.
Of course.
It's great to have that group dynamic. That is what I learned from my first shower, is that you always have to have that person that's missing the streaks. And if you have a group of people watching the meteor shower and you think there's no one in that group that's missing the streaks, then it's you. Just letting you know.
Exactly. Excuse me. Well, you do group presentations at the Morrison Planetarium. What are the reactions like from the people?
Oh, in terms of so there's a lot of different, topics that we cover over at the Morrison Planetarium, learning about different, constellations in the sky, learning about there's different shows on different subjects. And generally what we tend to get from people when they talk to me after the shows is just this sense of awe and excitement about the universe. I think there's actually a lot of people like me out there that haven't had a direct sort of conversation and connection with astronomy in their childhood, where this is a way to go to a planetarium or to go and look at the Slooh ride.
We just saw one, Eric.
Oh, yes. Yay. Oh, that's wonderful.
And it was on the screen for a good long time. That was terrific. I'm sorry, I interrupted you. Go ahead.
Oh, no, that's wonderful. See,
It's
yes,
good. It could be the start
long
of something big.
Yeah, when you wait long enough, you get that opportunity, you get that streak, and it's great that Slooh's always on for such a long broadcast for these meteor showers. Because even if we don't see something right away, then we'll head into it, and maybe this is us heading into the peak. That would be lovely that we start to see more and more as the night goes on. But it's just that opportunity to, you're looking at the night sky. It's familiar to you. It's what you've been used to seeing when you look up all the time. And then there's that break. There's that pause in the familiar, and you see this streak of light that sort of brings to heart that there's all these moving parts in our solar system. There's cogs in the machine that are turning, and we don't see a lot of the things that are flying around us. But sometimes there are these little specks of dust, these little debris, these meteoroids that collide with our atmosphere, and we see them light up. And I don't know, it's, for me at least, it's something that's a really connecting experience to sort of the rest of the solar system out there, that, there's stuff out there, and they sometimes come near enough to us.
Oh, there is stuff out there. And Eric, you've had a different perspective. You've actually been in the Slooh production studio for Meteor Shower Nights. What was that like?
Oh, so yeah, and I'm sure there's a lot of people in the studio right now that are having a similar experience where I mean, maybe the first reaction someone might have at a meteor shower is to try and look up at the sky. But when you're in the studios trying to sort of create a meteor shower broadcast, I was sort of working as a producer for Slooh, sort of behind the camera for a reasonable amount of time. What we were doing is we were looking at different feeds. We were sort of creating this broadcast and sending it out to the world. And that's, so looking at a computer screen to find meteors as opposed to looking up in the night sky. And there's definitely, pros and cons to both approaches. Particularly for me, the experience that I got when I was sort of working on creating this broadcast sort of with the Slooh team was this amazing sort of sense of collaboration, because there were so many people involved, including the people in the studio, the people that are providing the feeds, the Slooh members that are watching from around the world, and other people that are looking with their own cameras, their own eyes, and reporting their own streaks that they saw throughout the sky. And so the process of being in the studio or just being really involved in watching or looking at the Slooh broadcast is a way of sort of experiencing astronomy as a team communal experience, and sort of hearing these sort of cacophony of voices that are bringing in their different perspectives about this event. It can be a time when you don't see streaks all that often, like we were experiencing here sort of in the first hours of this Quadrantid broadcast, that there's not too many sort of immediate sort of payback. Oh, there's that streak of light, but there is that teamwork, that community effort that sort of brings in a sense of excitement and just sort of builds up this passion about astronomy, that we're all here to sort of look for this stuff. And it's very heartening to see. But then on the other side of things, there was actually this one broadcast that I was working in the production studio. I think it was the Orion, is a couple years back. And when I'd done that 6-hour broadcast, we'd seen a couple meteors. We'd gotten really excited about it. Then all of a sudden, at the end of the night, sort of around 2 a.m., I was sort of driving back to my apartment, and I walked out of my car and I looked up and I just saw one.
Oh, no kidding.
And so it was this amazing contrast of where we had this whole orchestration of effort that we'd put together to make this meteor shower broadcast happen on Slooh. And then at the same time, I just walk outside, and just in one moment, nature says, "Hi, Eric. Nice to see you. Just wanted to check in." It's when you have a cloudy sky, you can't quite do that. So I'm glad that we have this broadcast for people that can't see it with their own eyes. But it was a striking contrast for me, at least, certainly that night.
Well, Eric, that's also part of the allure of meteor showers, isn't it? The predictability and unpredictability of them.
Absolutely. So we know when these meteor showers happen. So, Earth has its 365-day orbit, and we know that there are certain places in that orbit where there's a bundle of rocks and debris, these meteoroids. So we know sort of at certain times when there's going to be a meteor shower. But at the same time, we are not measuring precisely where each small particle is in space. So we know that this group of debris will hit us, but we don't know exactly when and where each streak will appear. There is that definite note of unpredictability. We know that we look up at the sky and there's going to be a good chance right around now, but we can't say for sure. We can't make any guarantees. And I really think that's part of a meteor shower's allure, is that you can't predict this. It's not like the International Space Station where you can have a special app, you know exactly what time it's going to come across. There is that guesswork involved and that sort of hope and wishing on stars, wishing for shooting stars. And it's a bit of an adventure on these nights.
Eric, do you have a favorite meteor shower based on where you live now?
A favorite meteor shower. Well, so personally, I gotta say, I do love the Geminids. They were my first shower. And also they're in that winter time of year when you get those crisp, clear nights. It's a great time in the midst of meteor shower season where you're starting to have a lot of meteor showers back to back. And all of a sudden the Geminids really shines through as this amazingly populated shower that really most times of year, even this year when we had a full moon, the Slooh broadcast was amazing. It was just jam-packed full of a lot of different streaks. That was so fun. And so yeah, I really like the meteor showers that guarantee you a good time regardless of sort of the moonlight that's going on. And so definitely Geminids would have to be my favorite. What about you, Jerry? Do you have a favorite
Eric, I
shower
hate
out
to
there?
interrupt, but do you see the flashing light moving through the screen, the top of the screen?
Oh, yes, yes. So that's pretty slow moving. Are we seeing sort of maybe an aircraft up there?
Yeah, that's what I think too.
Yeah, it would be lovely if we had just a nice slow meteor meandering through the sky, but
That
all
would be
likelihood
cool.
we're seeing human stuff going on. But there's definitely action out there. It doesn't have to just be meteors. It could be aircraft. It could be, a satellite. There's lots of stuff out there to spot.
All right, we will keep our eyes peeled, and as I mentioned before, we are ever hopeful and ever vigilant. All right, Eric, we're going to step away. Thank you so much. Eric will be back in just a few minutes to talk about comets. And coming up on the show, Paul Cox will be back one more time to take a closer look at our live feeds, and we'll dissect those momentarily. And later, I'll be talking to our human spirit correspondent, Helen Avery, once again about the constellation that produced this particular meteor shower. So don't touch that mouse.
As we celebrate our 13th anniversary, we're excited to bring you the all-new Slooh.com. With an all-new reservation system, brand new telescopes, and introducing Slooh Recommends. We're bringing the universe closer than ever before. Coming soon to Slooh, where there's space for everyone.
As we welcome you back to our live coverage of the 2017 Quadrantid meteor shower, Jerry Montour here with you, keeping a close eye on our global live feeds. And once again, to talk about these feeds is our friend Paul Cox, Slooh astronomer. And I came up out of my seat, Paul, because I saw what in my opinion is a very slow moving meteor. It was terrific.
It was. Well, the direction that we're looking in this particular view is quite a long way away from the radiant. And the further away from the radiant, that place in the sky where they appear to radiate from, the further away you are from them, you tend to get a longer trail. Because if you're looking at the radiant, they're coming directly towards us. So you only see a very short trail. But we've also got something else happening here in Japan. The night is wearing on there. They're about halfway through the night. So the radiant itself in Bootes, which you're going to be talking about a little bit later, is getting higher and higher in the sky. The higher the radiant is in the sky, the more meteors you get to see. And you can start seeing them then go off in any direction from the radiant. So the Japanese feeds are certainly the ones that we need to keep a close eye on now, because Hawaii, they're going to be in dawn. We're going to start seeing the sky lighten there. So we're going to be losing the Hawaii feed, but the Japanese feeds are going to get even better.
Yeah, in fact, I think I just saw a quick one there. My eyes might be playing tricks on me right now at this point, Paul, but I think I saw a quick one.
Yeah, quite possibly, quite possibly. So.
So we're expecting, since this is the middle of what we consider to be the peak, we're expecting what could very well turn out to be a meteor storm, not just a meteor shower. That's what we're hoping for. Is that correct?
Absolutely, and that's what you always hope for. Now, a meteor storm can last sometimes only minutes, but there have been occasions in history, and they've been written up, in history, and beautiful paintings and illustrations made of it. People watching in London in, what was it, 1830 or something like that, and the sky was lit up with these fireballs just raining down on you. I have yet to see a really fully blown storm. And when we're talking storm, we're talking a couple every second. You are just seeing whiz, 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 whiz. I'm really looking forward to my first encounter with a meteor storm, that's for sure.
Well, as we mentioned at the top of the show, if you were not with us, this has already been a big year for Slooh. And last week, some tremendous excitement here, correct?
Yes, we had another nova discovery by a Slooh member, Emmanuel Conseil, and he's discovered this nova, which is nova means new star, and it's a new star that he spotted basically in the Andromeda galaxy. So the star isn't even in our galaxy. There it is. You can see the Andromeda galaxy there going up to the left.
That's amazing.
And you can just see.
Wow.
Exactly. I mean, these are the kind of live views that Slooh members get of these objects. And you can see there, Emmanuel has marked where that nova is. And a nova shouldn't be confused with a supernova. A supernova is kind of the cataclysmic death throes of a giant star, a massive star. But a nova is normally a smaller star with a companion, and it steals the hydrogen off its companion star until suddenly there's this nuclear fission explosion and on the surface of the star, and that's what causes the rapid brightening. So Slooh members are now watching this thing and monitoring the nova every single night, because it's really important that we understand how that light dips so that we get to understand the physics of what's really going on in these enormous explosions.
Paul, for those who don't know, how easy is it to become a Slooh member?
Well, actually, I've been meaning, I keep forgetting, I've been meaning all evening, all afternoon here, to welcome all the new Slooh members who joined over Christmas because they were given a gift membership. So somebody loves you, don't you, when somebody gives you the gift of the universe. But all of those members, they can go into the clubhouse. It is really easy to use. This is using a half-meter, a mighty telescope on the top of a volcano in the Canary Islands at the Institute of Astrophysics of the Canary Islands from your front room. And it's as easy as saying, that's when I want to control the telescope, and choose from list. You'll see a great big list of objects. That's the object I want to view. It might be a comet, an asteroid, a vast nebulae or galaxy, or maybe a planetary nebula. So it is incredibly easy. And the new Slooh, which we're launching this year, which we're really excited about, makes it even easier, Jerry. But it's always easier than you think. And there's the best thing about Slooh, I always think, is the Slooh community. You've always got people around you to lend a hand, to give you some advice, so you're not kind of stuck in the middle of it on your own.
And people like Emmanuel leading the way, right?
Absolutely, and Emmanuel is very, very generous. He's actually written an article in the Slooh Clubhouse explaining how other members could start up a supernova or nova search for themselves.
And we are looking at one of our feeds from Japan now, and you say the sky will darken and increase our chances of seeing meteors here.
Yeah, the sky won't darken so much as the radiance up, and they've got the camera, sensitivity turned up quite a lot there, Jerry. So that's why we're seeing quite a light background, but that means that we can catch some of those fainter meteors. But the radiant is moving up in the sky. They're in the middle of the night. This is where it's where their conditions in Japan meet the peak. So this is kind of the peak of the peak, because we're under ideal conditions now in the Japanese feeds.
Paul, we've been talking about meteor showers and eclipses. Do you have a favorite celestial event?
I do, and they happen when they're least expected, and it's comets. And it's this comet that we're seeing at the moment, 45P. Nobody knew how much it was going to display a tail, and then suddenly it does. And Slooh members have been some of the first people to have spotted that activity. And it's monitoring comets. It's always the unusual. It's the unexpected. But from an event point of view, for this year, that's also going to be my favorite. Even though we've got these marvelous eclipses, I'm really looking forward to Comet 45P when it makes a historic close approach to Earth on the 11th of February. Now, that's going to be quite an exciting event because once again, we don't know just how bright it's going to be. There it is. And these are some of the images that we've been taking, that Slooh members have been taking over the last few nights. This thing could go large. It really could. It's just gone, it's had its closest approach to the sun. It's now disturbed, the sun's gravity has disturbed every ounce of that particular comet. So we could be seeing a really, really good display from that on the 11th of February.
All right, mark it on your calendars, February 11th. I'm on the edge of my seat already. Paul, thanks so much for joining us.
Thank you very much.
And Happy New Year to you. Coming up here on the show, Eric Edelman returns with more Meteor Showers 101. And later, our human spirit correspondent, Helen Avery, back to talk about the origin of the Quadrantids. No surfing, people. Stay right here. We're excited to announce the release of our first book, The Saturn Above It, an anthology of short fiction about space. Available now at slooh.com. This February, a ring of fire will rise over planet Earth. Millions will shadow as it races across the planet at supersonic speeds. The annular eclipse will make its way across South America, through Chile and Argentina, before crossing the Atlantic Ocean, making landfall in Africa, casting Angola, the Democratic Republic of the Congo, and Zambia into shadow. On February 26th, explore an eclipse like you never have before. Be a part of the wide event right here on Slooh. Space for everyone. And welcome back, everybody, to our coverage of the Quadrantid meteor shower. Jerry Monter with you here, hoping to catch views of meteors as they streak on by. We've got feeds in Hawaii and Japan. We've seen some meteors already, and now it's time to turn back to our friend in San Francisco, Eric Edelman, Slooh astronomer. Eric, let's just pretend I'm one of the newbies in one of your presentation groups at Morrison Planetarium. Let's pretend I know nothing. All right, what causes meteor showers?
So there's a lot going on there. We have our planets that are in circles around the sun, close to circles. They're not complete circles, but they're pretty much circular approximations. Then we have some other objects out there that are not quite in those circular orbits, that we have them, they're sort of in elliptical shapes, sort of stretched out rubber band-like shapes. So they get very far away from the sun, and then they get very close on by, actually passing through the orbits of some of the planets at certain points. And so some of these objects, maybe to get a little bit of vocabulary out of the way here, we have asteroids, we have comets, we have meteoroids, we have meteors, and we have meteorites. So asteroids and comets are those sort of bigger bodies that are flying through space. Usually we think of asteroids as being between Mars and Jupiter in the asteroid belt. We have comets out there that are usually located out beyond the orbit of Neptune at the Kuiper belt. And so they have their orbits way far out there, but sometimes if they have a really elliptical orbit, they can also pass closer by and things like that. And so with meteor showers, those happen because these bodies leave behind rubble piles in their way. Sometimes, particularly with comets, you get, when they get close to the sun, they sort of outgas. They're sort of dusty snowballs, so to speak. So they have these icy volatiles on them, which when they heat up, they can start to escape from that comet, so to speak. So you have these different objects. They're leaving behind these rubble piles. And sometimes, if that comet is getting in the middle of Earth's orbit, it will, or comet or asteroid, they will leave that rubble in Earth's way. And so as Earth makes its orbit around planet Earth, then at the same time every year it runs into certain rubble piles that these asteroids and comets have left behind. So these little small pieces of dust and rock and debris, these are known as meteoroids when they're floating out there in space. And these can be really, really small. They can be about as small as a grain of sand. And so really, really tiny things. But the Earth's moving really quickly through space. These grains are also moving pretty quickly relative to Earth. So when they collide with Earth's atmosphere, becoming a meteor, they can really make some exciting things happen in the atmosphere. Is they're zooming in at, I believe these meteors for the Quadrantids are about at 90,000 miles an hour. So amazing. I don't know if any of you have driven that fast, but it's pretty fast. So when they're zooming through the atmosphere, they're compressing the dust or the atmosphere in front of them, that gas. It gets really excited and it heats up. It ionizes. So it this really exciting event in the atmosphere, it creates this sort of streak of light as this gas gets ionized. You're not actually seeing the meteor itself, but the gas that is ionized and excited as that meteor passes through the atmosphere. There's sort of this excited trail of gas. And that end up seeing in these meteor showers.
I'm sorry to interrupt. The origin of this particular meteor shower, it's a bit different, isn't it?
Oh, it's so fun. I love talking about this. So the quadrantids. So every meteor shower has a radiant where they appear to be emanating from, because those rubble piles, they are all sort of in this one sort of same space relatively, and then that place they're all seem to be emanating from is known as the radiant. And so meteor showers, they're named after their radiant. So we have the Geminids, that's named after Gemini, the Orionids after Orion. We have the Leonids after Leo. So following that pattern, the Quadrantids, where are they emanating from? The constellation of Boötes. It totally makes sense, right? This this meteor shower is a great example of how much history is packed into astronomy and how much things have changed, and how names that don't make sense right now, they made sense a little bit in the past, but we've evolved our understanding of things over time. So in about 1795, there was a French astronomer that named a constellation right around there called the Quadrans Muralis, or the Mural Quadrant. And then in the 1830s, people were starting to notice this meteor shower occurring from that region. So they started to call that meteor shower the Quadrantids. But then in 1922, I believe it was, the International Astronomical Union decided to standardize things. There were a lot of constellations out there, but they wanted to have a standard that everybody could go by. So they cleaved the sky into 88 specific constellations. And so those are the constellations that we sort of know of when we stargaze today. The Quadrans Muralis was not included in there. It actually was partially cannibalized by Boötes, what the modern day Boötes is. So in the way past, this name Quadrantids, but now it's sort of an artifact of our time as our understanding and our classing of the sky has evolved. So sort of a fun story.
And it emanates from a dead object, or do you consider that object to be dead? I'm speaking of 2003 EH1.
Yes, yeah. So I've heard some speculation on that there's the possibility. So I was talking a bit about comets and asteroids. And while we have divisions and we have classifications for each of them, there is some intermingling, some intermixing. Sometimes you'll see comets that are nearer to the asteroid belt, and so you'll see comets that are closer in. And in particular, one possibility for 2003 EH is it's a body that really doesn't appear to be comet-like. It doesn't have a tail that's that's that outgassing that we're familiar with. And one of the possibilities is that 2000 EH could be what's considered a dead comet. So that in the past, it was having this huge outgassing, that there was the icy snowball, but it got rid of all that ice and things like that, so that now it's no longer outgassing in that way. And so now it looks more asteroid-like in appearance because it doesn't have that magnificent comet tail, but it could have been a comet in the past. So has it been an evolved comet, or was it always an asteroid? It seems more likely that it was a dead comet. So there's a lot of sort of crossover between not only the appearances, but also sort of where you find these bodies in the solar system. So there's a bit of a gray area. It's not black and white when it comes to comets and asteroids.
Well, I realize this is purely conjecture, Eric, but your best guess, if it is a dead comet, when did it die?
Oh, that's a great question. So there's speculation that this comet, or this possibly dead comet, might have been related to a comet that Chinese astronomers observed about 500 years ago. And so we have a period of time between now and then when it could have possibly died. And so there's the question that if this was the comet that was supplying us with this meteor shower, if it died sort of a significantly long time ago, maybe we could be nearing the end of our time experiencing the quadrantids. Because once the object that's orbiting or crossing Earth's orbit tends to stop giving off its material, then that's when we stop getting the meteor showers that we experience. And so my best guess would be that maybe, 100 years back, it might have run out of time, and maybe now it's not contributing quite as much. So maybe in the future, we might see a dropping off of the quadrantids as that material continues to be eaten up in progressive showers. But again, highly conjecture. So could be different.
Sure. So if comets are dying in our lifetimes, comets must be coming to life then too. So might we not see new meteor showers in the near future?
So the way we might see new meteor showers actually might have to do with short period versus long period comets, because we have comets like, Halley's Comet that come by, every, I think it's 70 years or so, somewhere around there. We have comets that within, less than 100 years or within 200 coming by Earth frequently. So they're replenishing their trash heaps, so to speak. So those are the comets that we have more near the Kuiper Belt and closer in. But then we have longer period comets, and those are coming from an object known as the Oort cloud, this distant sphere of rocks and debris that orbits our sun at sort of the very outer edges of our gravitational influence. So to give you a conception of just how far this is away, the distance from the Earth to the sun is about 8.5 light minutes, which comes out to 93 million miles. The distance to Neptune, the farthest planet and where the Kuiper Belt sort of starts, is about 4 light hours. The distance to the Oort cloud is 1 to 2 light years. So it's very, very, very far away. So you're talking about comets that will have orbits on the order of thousands or tens of thousands of years. So they might come by our planet at one point and they'll outgas at that time, but since they're not coming by the sun so frequently, they really won't lose their material over a very, very long period of time. So every time they come by, they'll have that outgassing experience. And so, but at the same time, they really won't come by all that often. So maybe, once one of those comets that's really a long period comet will pass by, we'll have a meteor shower related to that comet, but that meteor shower will eventually die down since that material is not being replenished. Then after tens of thousands of years, maybe we'll see another one once it comes back once again. So there's a real big variety of objects out there that can deposit material for us, and just different stories that they can tell of objects really that come in from very, very far away, from very, very long trips.
Well, as they say in the business, you never know. And that, folks, is why Eric Edelman gives presentations at the Morrison Planetarium. Eric, we'll be right back to talk with you more, and we'll hear from you how we can hear meteors as well as see them. And later on, I'll visit with our human spirit correspondent, Helen Avery, about the constellation Boötes. Please stay with us. We're excited to announce the release of our first book, The Saturn Above It, an anthology of short fiction about space. Available now at Slooh.com.
diathesis from the antenna.
And we welcome you back to our live coverage of the 2017 Quadrantids meteor shower. I'm Jerry Montour. We're watching our live global feeds from Japan and Hawaii, hoping to catch a glimpse of some of these bits of fiery space debris as they streak through our low light camera lenses. Even if we couldn't see them, though, we could hear them. And back once again to tell us how that is possible is Eric Edelman, live from San Francisco. So, Eric, it sounds like so much voodoo to me. How's this work?
So light has different frequencies associated with it, and so we can actually see horizontally different frequencies, and then also we have intensities as well. Oh, so actually, yeah, so we have different levels of frequencies, and we have different intensities that come along with that light. And so what we're trying to do is we're trying to listen to when a certainty gets a little bit more intense. And particularly at live meteors, what they're doing is they're listening to a very particular frequency, which is about 55.25 megahertz. This is sort of where our channel 2 for our TVs for the video frequency sort of lies. And so this is certainly purposeful. We're actually looking with a TV tower that's emitting at a certain frequency. And what will happen is that radio frequency will bounce off of sort of ionized particles in the ionosphere and come back to an antenna where they actually have a Yagi antenna set up in DC. So we have radio waves being emitted. And then we have streaks of light that are coming to us from these meteors. These are ionizing the gas around them. These ionized gas, this reflects these radio waves, sort of like light in a mirror, say. And then that hits the antenna, and we experience a radio ping, so to speak. And so what we're going to be looking for is a really sort of short-lived, sort of a whistle sound that goes through, and that will end up being our radio noise that we hear. There's a lot to parse through here. If you have particular questions, I'd be happy to go into a certain subject or other regarding it.
Well, this is important. If I'm not mistaken, it's important because we can't always see meteors.
Oh, certainly, yeah. There's a difference. Sometimes there's a lovely sort of serendipitous occasion where we both see the meteor and we hear the meteor. That can be lovely if you're sort of in a similar geographic location with both your radio feed as well as your visual feed. In terms of, though, the radio feeds, you can hear a little bit more oftentimes than you can see. Sometimes the fainter meteors we're not going to be able to pick up with our eyes. And so these meteors actually, we're seeing them about sort of 50 to 65 miles up. And so it covers a decent sort of area of the sky. And even if there's cloud cover, you can sometimes hear those radio meteors a little bit better than you can see them when those clouds are covering up your sky.
Well, earlier in the program, Paul was talking about the fact that even folks at home can tune in and listen to meteors. Have you ever tried that, Eric?
Oh, I have not tried that myself, but I know that there's a lovely community of amateur astronomers, people that are, I believe it's radio hams might be the term, where they're very into sort of doing that themselves. And there's actually a wonderful call out there from astronomers that they want that community of amateur astronomers to be very active in terms of listening to these radio pings, because the more that we are able to detect, the more we're able to classify these radio pings, the more we're going to start to learn about the objects that are going by us. Because how that radio ping sounds, how that meteor sounds when we're hearing it through radio, that's actually telling us a little bit about that meteor, about how fast it's going, a little bit about, say, its composition, things like that, that we can learn from those radio pings. And so the more that we're able to sort of collect those pings as a group, as a community, the more we're going to start to learn about the meteors that are coming through our night sky. So again, Slooh itself is this wonderful collaborative community where we're working together to sort of see and experience the night sky and looking for radio pings and meteors themselves. That's also a really fascinating way to sort of come together and search for things out in the sky.
I would imagine you also, excuse me, also have to be pretty aware of what you're listening to. I mean, it might be a little confusing out there. You might think you're listening to meteors when you're actually hearing something else, correct?
Oh yeah, absolutely. And so we're sort of looking at this sort of line coming across the screen here at the top left, and all of these bright spots that you're seeing, those aren't necessarily meteors. I would say that pretty much a majority of them would not be related to meteors. So you have these longer streaks. So if you're seeing or you're hearing something, or you're seeing it through this visualization of what you're hearing, how deep does it go? Either way, it's probably going to be another object. There is actually, so in the ionosphere, named ionosphere for a great reason, because you have ionized particles up there. During the daytime, it's a lot harder to listen for radio pings because there's a lot more going on out there. Because a good reason why ionized particles out there is because of the sun and the solar wind, the particles that are coming toward our atmosphere and are ionizing that ionosphere region. And so we also do have some ionized clouds of particles even during the nighttime. And so when the radio waves hit these ionized particles, that's going to be a radio ping or a radio noise. And so the longer lasting ones can be related to ionized particles that don't have to do with meteors, so to speak. So you want to be very careful about what type of sound that you're listening to. It should be very short-lived. You should also maybe see it sort of spread out a little bit in frequency. Like it will be centered right around the frequency that you're looking for, around 55.25 megahertz for this one in particular. But there's going to be a little bit of a spreading that occurs, that it's a little bit of a Doppler shift, so to speak.
All
So
right,
very short-lived
Eric,
and a little bit of a whistle.
it's great stuff. Not only Meteor Showers 101, but Radio Technology 101. Thank you so much, Eric. Have a great day. Thanks for joining us.
You as well. I hope you have a great rest of the hour here, Jerry.
Hoping for a meteor shower, hoping for a meteor storm. Coming up on the show, our human spirit correspondent, Helen Avery, will return to walk us through the mythology behind this particular meteor shower, and that's coming up right after this.
As we celebrate our 13th anniversary, we're excited to bring you the all-new Slooh.com. With an all-new reservation system, brand new telescopes, and introducing Slooh Recommends. We're bringing the universe closer than ever before. Coming soon to Slooh, where there's space for everyone.
We're excited to announce the release of our first book, The Saturn Above It, an anthology of short fiction about space. Available now at Slooh.com. And we welcome you back to our coverage of the Quadrantid meteor shower here on Slooh, Space for Everyone. I'm Jerry Monteur, and it's now time to welcome back our human spirit correspondent, Helen Avery. So, as we know, meteor showers are named after the constellation they appear to originate from, and in the case of the Quadrantids, it's a little unusual as the constellation they appear to come from no longer exists. Isn't that right?
Yeah, it's from Eric and Bob earlier. So it's not so much it doesn't exist because the stars are still there, but it's not really recognized anymore. It's just not something we talk about. This Quadrant Miralis. And so it can be a bit of a loss to find this one in the sky, to be honest, because, you know, as we know, as you just mentioned, like meteor showers are named, or they look like they originate from a constellation. So where is this constellation that we're looking for tonight?
Yeah, that's the question. Where exactly in the sky would we be looking to guide us to where this shower originates?
Right. So Quadrant Miralis was roughly between Boötes. I think that's how we're saying it, Boötes.
That's how I'm saying it.
Right. And the tail of Ursa Major, the bear. And if you think of Ursa Major more as the plow or as the Big Dipper or the huge saucepan, it's at like the end of the handle. So it's between Boötes and Ursa Major. And for that reason, the Quadrantids are sometimes called the Boötids instead, yeah.
All right. Understood. So the Boötes pretty easy to find?
Well, they are. I mean, it's funny. It's such an interesting constellation. It's not one that sort of springs to mind when you're thinking about constellations in the sky, and yet it's probably one we've looked at so many times because it's right up there next to the Great Bear or the Big Dipper. And I don't know about you, but as a child, when I was learning about the sky, the first thing you looked for was the pole star, and then you found the Big Dipper, and Boötes is just there. But no one ever said, oh, you know, by the way, that's Boötes. And it looks a bit like a kite, although it's supposed to be a man. Depending on, you know, where you are in the world, you'll see it differently, I suppose.
Okay, sounds like there might be a story there. Kind of an unusual name. Anyway, Boötes, where does that come from?
It is, and maybe that's why we don't talk about it, because no one can pronounce it, Jerry. I don't know. That's why we've just kind of ignore this one. But it is really interesting. Mostly around the world, it's agreed that this constellation, this kind of kite, is a man who is upright. It's not always agreed on what this man is doing. So in Arabian legend, this upright gentleman, and everyone agrees on this actually, is holding a leash in one hand with two dogs, and that goes off to the constellation Canis Venatici. And in his other hand, in Arabian legend, he's holding a shepherd's hook or a staff. And he's known as the Great Shepherd, the Good Shepherd, the Shepherd of the Heavens. And it's really beautiful because in Arabian legend, the pole star was seen as a sheep pen. And that all souls were being gathered by this beautiful shepherd of the sky into this sheep pen. So really, really lovely. And even the early Catholics agreed with this interpretation of the constellation. And so we can imagine that perhaps Ursa Major was seen as a wolf, or, you know, a fox, or some sort of hunting dog, or even a bear still, that was going to attack the sheep. Now, the ancient Egyptians saw Ursa Major as the bear. So they saw this upright gentleman as actually a bear driver. He was herding or guiding a bear. But it's the Greeks who kind of gave us this Boötes of today, in that they saw Ursa Major as the plough. So they called this gentleman the ox driver. So Boötes means literally to drive the ox, and that's what they say he's doing around the sky. So we can blame the Greeks for this
Okay.
unusual
Happy
name.
to blame the Greeks. Well, it sounds like it was a pretty important constellation to all of humanity, really, right?
Yeah, and it's so interesting because, as I say, we don't really talk about it. And I wonder if that's because the stories aren't as strong as some of the other stories that we have in the constellations, like Orion, for example, that story of the Great Hunt across the sky. Um, but it wasn't just, Boötes is up there with the pole star, so it's extremely sort of important. Within Boötes is Arcturus, which is the fourth brightest star in the sky. And the ancients thought that Arcturus was the nearest star to Earth, and they used Arcturus to guide them. And I was hoping we could see Arcturus on the screen, but I think we just moved in Japan. So I think it's gone, but it might
Yes,
be in
this is
Hawaii
Japan.
feed.
Yep,
Certainly
yep.
Ursa Major you can see very clearly in Hawaiian feed. But it was so important. It was actually mentioned in the Bible. Now, not many stars get a mention in the Bible, but in the book of Job, Arcturus is mentioned. Also, many poets mentioned it. Virgil mentions Arcturus. The lovely Sufi poet Hafiz mentions Arcturus. And it was really important for seafarers. So I'm told that even today, Eskimos use Arcturus when they go seal hunting at night in the months of December and January, and it gives them a guide to how the night's passing. And then, entirely different part of the world, and many, 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 many years ago, the Polynesians used Arcturus as a guide for them when they were paddling in canoes towards Hawaii. And interestingly, they use Sirius, the star, when going towards Tahiti. So it's a beauty, a Boöte of a constellation when we start to think
Oh
about
God. Okay.
it. I know, silly.
And there's another story out there. It involves Boötes and a hangover. I'll let you take it from there.
Yes, there is that one. And it's one that perhaps we can all relate to just after maybe some
Oh yeah.
partying rather hard over the new year. So aside from being this ox driver, there is one Greek legend about this constellation, and that it is a gentleman called Icareus. And it's said that Dionysius, the Greek god of wine, so the same as the Roman god Bacchus, which sometimes we're more familiar with, came to Icareus and taught him how to make really good wine. And Icareus, being a very generous, kind soul, took a bottle that he'd made to some local shepherds. And the local shepherds partied very hard that night. And
As
when
shepherds
they
are
woke
wont to do. Yes.
when they woke up the next morning, they felt like death. As sure, we've all been there. Only they'd never drunk alcohol before, so they had no idea that what they were feeling was actually a hangover. And they thought that poor old Icareus had tried to poison them. So they went off in search of him. They took him from his home. Typical Greek tragedy. They drag him to a field and kill him and put him in a shallow grave. And then his daughter arrives, Erigone. She arrives back home, knows something's wrong. So she takes their two dogs and goes hunting for her father, comes to his shallow grave, is overtaken with sorrow, hangs herself on a nearby tree. I know, typical. It's such a classic tragedy. And
Yeah.
the two dogs, loyal servants, stay by the bodies of their owners until they too die of starvation. And so Zeus looks down at this pitiful four and decides to put them in the sky. So that's why we have this constellation, which would be Icareus instead of Boötes. We have still the two dogs, Canis Venatici, and then Erigone, the daughter, is actually embodied in Virgo, the maiden, which is not too far off. We can't see it in this feed, but it's not too far off Boötes. So yeah, a lesson to us all. Be careful who buys you drinks or something.
Yeah, I can relate to that. I've known a few bartenders I've wanted to kill over the years.
Right.
Now back to Arcturus for a moment. I know there's another story here, something about Arcturus in the World's Fair of 1933.
Yeah, and it's a weird one. I have no idea if it's true, so I would love to hear from the community if they have heard about this. And I've taken some notes because it's very, very obscure. So it said that in 1893, the World Fair was in Chicago in 1893, and that was the year that Arcturus lost its light. But obviously we still see the light of Arcturus because it's still coming our way. And so 40 years later, in 1993, as you said, 1933, as you said, Chicago gets the World Fair back, and they decide to sort of celebrate Arcturus by harnessing its light and using the power to light the beginning of the fair. So I'm just going to read what I wrote because I don't understand it. But if someone out there has heard of this, I would love to hear if this is true. So it said that the organizers focused the beams of Arcturus on a photoelectric cell and generated electric currents that turned on the lights of the fair. Now, that sounds amazing to me that they were doing this in 1933. So I would love to hear if this is true.
That's a story that I hope is true. Hey, Helen, thank you so much for everything as always, and Happy New Year to you.
Happy New Year to you.
I appreciate that. Well, that about does it for the Quadrantid meteor shower this year. I want to thank the rest of our guests today as well, Eric Edelman, Bob Berman, Paul Cox, and Helen Avery. And of course, I want to thank our partners at Weather News Japan, who provided a great feed for us today. We hope to see you here for our next live show here on Slooh. You won't have to wait long. On January 12th, we're celebrating the first full moon of the year, the full wolf moon. We got lots of great shows on the way in the coming months. The very first solar eclipse of 2017 right around the corner in February. The Ring of Fire will sweep across South America, the Atlantic, and parts of Africa on February 26th. And we're already making plans here for the big transcontinental eclipse on August 21st. The total solar eclipse making its way across the whole of the U.S., and Slooh will be on hand to capture the entire thing. Be sure to follow our ongoing coverage of this once-in-a-lifetime event. We'll hope to see you on a future show, but that's it for today. I'm Jerry Monteur. This is Slooh, Space for Everyone.